Welcome to another NSF live show. Today will be the third in our Europe's Future in Space series. This is a series of live stream episodes where we talk to officials in the European space industry so that you, the audience, get to know them better. At the same time, with these live streams, we're letting them have a space to talk all about the cool stuff they're working on for Europe's future in space. Roll the intro.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, roger, planet.
Water towers, fly! Yes!
Tango down to nominal.
Flight downside SPD off. Bring in SPD off. Off. It's orange! 145!
Oh my god!
Decollage.
What is it?
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
The methane would be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
Well, welcome everyone again. And, we're going to have lots of fun today because if you watch the previous two episodes, we've got PLD Space, High Impulse, we've got rocket companies on those. Today, we're going to have what I call a camera company, even though they probably will call themselves something different. But we have SEN, London-based SEN, and we have none other than the CEO of SEN, Chares Black. Welcome to the show, Charles.
Thank you for inviting me on the show.
And of course, we always have as well our chat. You can tag at NASASpaceflight in chat as always, and we can ask Charles a lot of questions from the public. But that's what DWise is here for. DWise, do we have you here?
You sure do. And so be sure to tag your questions in chat and I will get them all put together so we can pass them along.
Yeah, we always have, some questions already ahead of time because we are also curious about the things that these companies are doing, of course, and especially SEN, lots of camera things. And I know you know a lot of camera things, D. But definitely, we're going to take some of those questions from chat, again, at NASASpaceflight in chat, and we're going to try and answer those questions. Also, thanks to Jay for operating the live stream. Always very helpful for that. And of course, now we got to get down to business. And one of the things that I'm really curious about every single time we have a new company here is, Charles, how did SEN come up to be? Like, there's no SEN, and then suddenly there's a company called SEN, and it's there. How did that happen?
Well, it's been a long time in my mind. So when I was at school, I was thinking of what sort of business I wanted to run because I felt like I wanted to be entrepreneurial and get up every day and do something constructive and creative. And I came up with the idea when I was about 18 because I grew up in York. I used to look up at the dark skies and see all the stars. And I used to just think, it's amazing that we live on a planet, and the reality of this existence on a planet is not something that people maybe think about too much because everyone's busy with their day-to-day activities. And I thought, well, if you look at Earth from space, you see things differently, you get a different perspective. And that's when I thought, what I need to do is send video cameras into space so we can capture news and information about everything that's happening on Earth, and as we explore beyond Earth, into the solar system, tell that story about humanity's exploration of space. And at the sort of heart of the idea was this idea of broadcasting it to everyone and democratizing space in this way. And I think when I was looking at the type of business I wanted to create, I was focused on getting rid of boundaries. So I didn't want geographical boundaries. I didn't want to sort of, for example, open a shop which was limited to one particular town or city. So I ended up finding this sort of instinct where I wanted to create a business that had the best chance of going on forever in space and over time. And this started troubling me as to like how could this go on, and sort of thinking, what if we need to get to the stage where satellites with video cameras can then manufacture more and more cameras, so once they get sort of way beyond where humans are traveling to. So that was the whole idea, and that was sort of back in 1990. And I was really excited that I had this idea, but I couldn't do much about it right at the time. It was before the internet, so there was no global platform like YouTube for distributing video, and space was very much government agencies, and rather than private space. So I set about actually went to university, did a law degree, qualified as a lawyer, and then I started an internet company in my bedroom. I call it Space Internet because the original idea of that company was we'll put companies online and do videos, and then I'll start making TV shows about space, and then eventually I'll earn enough money to then send satellites into space. But when I started that company, no one wanted to put video online because it was sort of dial-up modem days. There wasn't any high-speed broadband internet anywhere. So I ended up sort of pivoting to just be a hosting company. So we ended up hosting applications and software and doing cloud computing for companies. And I was did that for about 15 years. By about 2008, I was desperate to start what is now called SEN. And because that was my dream that I'd had by that time for about 18 years. So I started thinking of a name for it, and I was looking at acronyms like space exploration, and I found sen.com. So I bought the domain in 2008. And then I had to wait really until I could sort of exit from my internet company, which was listed on the London Stock Exchange. So it wasn't something that you could just sort of walk away from as a public company. And I had my first duty was to the shareholders and investors in that business to make sure we were successful with that. So I managed to exit from that business in 2014, and that went on. That company acquired several other companies after that and grew into quite a large company. So really 2014 was when I sort of started having the freedom to finally set about the idea. And then I spent about a year and a half working out how to do this. And then we hired our first engineers in 2016 and set about starting it then. So it's actually been a long journey, but we've not, as we've gone over the last few years, what I call like phase one of the business has been like hire the team and have a team of amazing engineers, and hire the team and develop the technology and prove the technology in space. And we've been very low profile during that phase because I'm always one, I don't like to talk about anything that we've done until we've sort of done it. So I think the first time we ever said anything publicly was after our first mission, which was we put 6 4K hosted cameras onto a satellite, and that was in 2019, and that was the first time we really sort of said, right, this is what we're doing, and this is what the plans are. So that's sort of a long answer to your question, but that's the long background. So this isn't a sort of space is trendy, let's do that. This has been sort of, I guess, like over 30 years, like planning to do this with, and I'm sort of driven by this idea that there's 8 billion people on the planet, and that reality of our existence, everyone should be able to see Earth in the same way that astronauts do, as if you were looking out the window of the space station, and everyone should be able to have that perspective of life on Earth. And as we explore beyond Earth, we're telling the story of that. And that, again, I feel that needs to be like an independent media, that there's government agencies doing things from different states, there's private companies doing things, and we all, as humans, have sort of a right to understand, what is going on, and to sort of to have a say in it, really, because the future is really for all of us sort of determined on the basis of informed consent, and that's really the background to SEN.
Well, you went through a lot of different questions that I had already prepared, so that's great because it kind of gives me more room for other questions. But yeah, especially the one about why SEN as the name of the company, because that's that's literally what I see on the chat right before we went live, I saw a few people already, making that question in chat. I know I stole part of Dee's work here, but I also have the chat next to me, so I can look at that. And yeah, I mean, it's quite interesting how a company, can just be, not being there, right? And then be like, I want to do this. I really want to set this up. And your goal of like, democratizing space and setting up live streams from space, I think it's really amazing because it's like we're not used to that. Like we're used more like CGI on movies and things like that. And there's a feed on the ISS, but it's not really that high resolution. Like you probably want to have a great understanding, right, of truly how being in space and looking down on Earth really looks like. And again, I've been sometimes with like there was a recent live stream of your feed from the ISS, and it was capturing Dragon docking, and I was just I was like, I don't care if it even docks or not. This is cool, right? And so yeah, I very much agree with that sentiment. One of the other things that I wanted to talk about, you talked about those beginnings around 2019. What did you guys do to get started, right? Like, what was the first thing that you guys did to get the ball rolling, so to speak?
Yeah, the first decision really was like to develop the technology ourselves rather than going to a company and saying, can you build us a payload that will stream video? Because it didn't exist off the shelf, and everything that we've developed and continue to develop is a custom built computer essentially with custom optics, and we can talk about that later. But so that was the first main decision. We say, look, we need to do this ourselves, and so that we own it and have a degree of control over it. So literally from capturing the data in space down to the end users, we sort of can have control of that whole data chain. So that was the main first decision, and it was quite difficult to start really, because in fact we spent the first year, to be honest, time could have been better spent, shall I put it like that, because we actually took an off-the-shelf video camera and thought, right, we'll fly this under a high altitude balloon and we'll test some remote zoom functionality and other things, just to see the idea of, can you actually just take an off-the-shelf commercial camera and put it into space. And we realized that didn't work, partly there was, we got, because of, again, being in the atmosphere with a high altitude balloon, you got condensation on the lens and the zoom didn't work, and it was all a disaster really. So after that, we set about focusing on just working on the electronic side of it to say, right, how can we sort of capture data through a camera sensor and process that data and then turn that into a stream. So that's what we started. And I thought one of the most effective ways to start would be with hosted cameras, because the electronics, the payload, the computer is going to be the same whether it's in our own satellite or in a hosted system, but it's going to be lower cost to build a hosted system and get it into space that way. And we got the opportunity to put some video cameras onto a spacecraft built by the Russian spacecraft prime operator RSC Energia. Quite famous for, they built Sputnik 1, the world's first satellite. They built Yuri Gagarin's spaceship, and they now build the Soyuz and everything else that take astronauts to the space station. And they wanted to put 4K video cameras on a satellite, not to look at Earth, but for self-inspection, really. They had various deployables and moving parts on the satellite that they wanted to have visual verification of. The telemetry says it's working, is it moving as it should? And they couldn't find anyone to do it, and they'd spent 2 years trying to find someone to do it. And so I went to Moscow and said, yeah, we can do it, and I'll tell you what, we'll do steerable cameras too, so we can steer and get some nice imagery of Earth. And after a long process, we eventually managed, it was quite challenging, we managed to get that contract to do that. And we had sort of been working at risk anyway. I said, well, let's develop this hosted camera system, and we managed to get that delivered, and that worked, and that launched in February 2019 on a Soyuz, and they actually had the cameras on all running during the launch as well. And now we didn't have direct control over this, so we wrote the code so that they could switch the cameras on and steer them and do stuff through their interface. So we had no control over it, but they were very pleased with the results, and that they shared with us some of the videos that they captured. So that was how we got started, and then the next phase was, right, how do we put this computer that we designed with all the electronics into our own satellite? So we chose Nano Avionics, and we contracted with them to build our first satellite, which launched in January 22. It's called ETVA1. It's still operating in orbit, and that's really a sort of tech demo. So we have 2 different cameras on there, and as well as recording 4K, we can also live stream when we go over ground stations, but that's only limited amount of live video. So sort of for 1 minute as we go over a ground station, and we learned a number of lessons from that: how to improve the electronics even more, how to improve the cameras more, and how you do live streaming. So that was the second step, and then the next step became Space TV1 mission, which is on the International Space Station.
Yeah, I gotta say, when I first knew about SIN was precisely with that satellite that you guys launched on Transporter 3, if I'm not mistaken, on a Falcon 9. And I remember, like, it must have been maybe a few weeks afterwards that I saw these amazing clips of the Earth, just like the ones that we're seeing. This one, I think, is from the ISS, right? But the other one was from the satellite, and it was amazing the way that, you know, you can see the greens, the blues, and in such quality, right? That I don't know, like we've seen that usually on pictures and little clips and whatnot. It just feels more real, just because it's, you know, with a higher resolution. But again, also as well, I believe you also had a few live streams of that camera, if I'm not mistaken.
Yeah, that's right. Yeah.
Yeah, I remember watching some of those, like, back in the day. I guess it was not that long ago, but you know what I mean, right? That I was, you know, I was impressed precisely about how much quality those had, and I liked it because it's one of the things that's sort of missing in space. We have a lot of things inside of spacecraft, right? But outside of the spacecraft, it's very uncommon to even see rocket cams as well. And so I think that is a great thing to have, to be able to, you know, see more of the Earth from space. And one of the things that I was curious about was precisely about how to translate, like, how do you take a camera that it's here on Earth, and now you have to put it up there in space, like on that satellite first, right? And then on the ISS. Do you have to change anything specifically that is really complicated? Like, what are the sort of overarching design changes that you have to do to that?
So there's a number of considerations when building a hosted payload or a satellite, including you aware that when it launches, obviously you get vibrations, so you have to ensure that it's not going to fall apart. You go through quite extreme temperature ranges from very cold to very hot, so you have to spend quite a lot of time designing the thermal side of that, how the satellite is going to behave, how heat's going to radiate, and so forth, and at what temperature it, you know, will be fine, and what are the operating temperatures, and making sure that's as big a range as possible. You also have to think about radiation. Radiation is less of a concern in low Earth orbit, and you see with all new space companies launching satellites, a lot of them fly, you know, automotive grade or even consumer grade electronics with sufficient protection around it, with shielding around the actual structure of the payload. And that's because we're trying to push, not just SEN, but other companies are pushing the boundaries of what's possible in terms of processing in space. And you can't go and pick radiation tolerant or radiation hardened components for everything, because they just haven't, because that takes time, that's really expensive to do the testing, and they're just not mature enough. So new space would be more agile and risky to say, well, let's actually fly this processor and let's fly this automotive grade component, and hope that it works. And all the evidence, not just from ourselves, so our satellite's been in orbit and operating successfully for over 3 years now, and our first mission, as far as we know, is still operating. So we do gather that evidence. There's there are some components that we have that are radiation tolerant around, for example, supervisor processors that are monitoring the sort of health of the system. So there's certain components where you want to be never fail. And we've also tried to design components where there is potentially a path to a radiation hardened version of that component for when we do put cameras, as we're hoping to do, into geostationary orbit and around the moon, into deep space locations where radiation environment is a lot harsher than around low Earth orbit. So I'm just trying to remember if I'm answering your question properly, which was just about all the things you have to think about and design changes. So
Yeah,
I
the
think
list is probably endless, right?
so you've got to think of all these things, and everything's a trade-off because, of course, you have power and bandwidth are trade-offs, and you might think, well, if you want loads and loads of power, well, then you've got to have loads and loads of batteries and then mass, and that all won't fit into the volume that you've got. So then you limits the amount of power you've got, and how many solar cells do you need, and what's your average orbital power, and then that might drive certain design considerations. How much redundancy do you put in? So there's an element, for example, Space TV is a what we call dual string. So we've got basically two of everything in there. So we've got 3 camera views, and there's 2 cameras looking at each view for redundancy. But that's one way of achieving it. Again, trying to de-risk the mission. But if you start doing that with satellites, then they start getting a lot more expensive, because then if you say, well, we'll have 2 radios for downlinking, and then we'll have 2 of our video computers on board. But then each camera's only got 1 sensor, and then you can't have 2 sensors per camera. So do you have 2 cameras of every view? And it all impacts mass, power, bandwidth. So it's usually a trade-off, and compromises have to be made. And I would say the engineering for space is what really impresses me is that that it's got to pass vibration testing, it's got to pass thermal vacuum testing, and it has to go through EMI testing, and they're all very, very intense, particularly to get on the space station, which as a human outpost, there's a huge number of safety requirements that with 3 NASA safety reviews for every mission to make sure it's safe. And so you've got to sort of address all of those things. But the space engineering is amazing because it's designed in such a way to say, right, we've got to make sure it's going to pass all these tests along the way, and design considerations are made, and everything is analysed. So you do thermal analysis and prediction, and when you're designing within CAD, components, everything's thought through in terms of vibration and how many, even down to some mechanical engineering, metalwork, structure. It's all sort of designed and tested so that by the time it gets to testing, you expect it to pass of those tests. I mean, so far that's the way it's worked out for us, and I think with other space companies as well. So you have to really focus on reliability of the components in the system, because it does go through quite a rough ride to get into space, and then when it's there, it has a pretty tough time with thermal and radiation.
Yeah, I can imagine just having to go through, especially the safety considerations from NASA and everything. It's all, very set in stone, and there's people on board of the ISS. Of course, that's one of the things that probably takes most of the time there. That's one of the things that I also wanted to come up into the show, which is you guys have those cameras on the ISS. Can you talk about what's the kind of design choices for that? Like, what is it all about? Because I know that there's multiple cameras and things like that. You've mentioned that just right now as well. So can you let us know about that?
Yeah, so on that, this is our first system, and we are working on a new system as well, which I could talk about, which just has additional capability. This first system, we had a timeline. We've decided to partner with Airbus US, which is our implementation partner, because they had built this platform on the European Space Agency's Columbus module called Bartolomeo, and it was designed to host payloads. So essentially they're sort of subletting part of the space station. And so we chose to work with Airbus, and we were given a sort of certain amount of mass, and we helped choose the location of where we could be on the platform because we were one of the first to do that. And yeah, then we sort of started by sort of saying, right, we wanted to be able to view. It was important to me that we did have views of the space station because and spacecraft and the docking port, because you want to connect humanity in space with people on the ground and telling that story that look, we've got people in space right now. So to film them arriving and leaving is important. And then we took the view that we wanted to have Earth's horizon in view for looking at storms and hurricanes, and just actually again just showing that reality of look, we do live on a planet. Not everyone understands that, but also we get those beautiful views of the horizon. And then we thought, but we also want to sort of have a look at right down at the ground, so we can see geography, events happening on large-scale events like wildfires or flooding, but also to see the beauty of the planet and the geology and mountain ranges and lakes and deserts and forests. And so we started with the idea that we should have those three views, and then worked backwards in terms of what the optics needed to look like. So we sort of set the principles of the field of view that we need. And we work with a specialist company that then actually manufactures those optics with glass that doesn't brown with radiation over time. That was just something we actually learned from our first mission. We flew with off-the-shelf lenses that cost €110 or something, and after about 6 months, you could see that they were going brown. So we learned from that, and then when the view looking down the ground, we wanted to go as detailed as we could, but obviously because the cameras that we have at the moment on Spaceflight are not steerable, obviously you're traveling at 27,000 kilometers an hour.
Yeah.
So you can't, for example, say, can't we have 1 meter resolution of the ground and see loads of detail, because of course it's moving so fast, and without being able to point the camera there, it would just be blurred. So we sort of optimized the scene size, which is about 240 kilometers by 180 kilometers across, and that is it just moves at a speed which I sort of feel has been really successful. It's quite hypnotic, and it's moving slow enough that you can see all the detail but also it's high quality in terms of optical and spatial resolution. So that was the thinking behind the first system, was to get those three views, and we had obviously on our first mission flown a steerable, so I was keen to have steerable, but we also had a timeline that we had to work to, which made that a little bit hard because we'd learned some lessons from the first steerable cameras, particularly around like internal cable management with pan and tilt, and we needed longer to be able to redesign that, improve that, and then test that. And we knew that in itself was going to be a sort of 18-month campaign, and that didn't really fit with the timetable of trying to get this core system up online as quickly as possible. So steerable cameras have been pushed to Space TV 2 that we're working on at the moment, and I'll be really excited to get those on board, because then we can point at things at Earth and be able to point at both docking ports and be able to steer those cameras, which will just give us additional capability from what we have at the moment.
Yeah, we're seeing here a graphic of where that platform is. So if, for people that might not be aware of the ISS configuration, it's like this long longitudinal axis, and then you have on the sides the panels, right? And right at the end, there's three modules. There's the primary module right at the front, then you've got the Columbus module to the right, and then you have the Kibo module from the Japanese agency. So you guys are on the Columbus module on the Bartolomeo platform, right?
That's exactly right, yeah, and we're just on that sort of corner nearest the docking port.
So you're in a perfect location to precisely capture those spacecraft coming in for a docking on the forward docking port. But as you mentioned, without tilt or pan and whatnot, you're not going to be able to see the ones docking on the Zenith port. So I'm looking forward to when you guys put those there, because I'm really, one of the problems that usually happens when and this is probably going to be a tie-in with another topic that I'm really curious about, which is space communications. Usually, when they have a spacecraft coming in from the zenith, and they try to dock to the zenith or undock from the zenith, usually that usually affects their signals and stuff like that, because they have some of the antennas on the upper side, and they also have to talk up to the geo belt and things like that. So that's going to be exciting if you guys can at least record that, if there's some, because I assume there's also going to be some signal issues as well with that. But I hear that your cameras can actually record that, and then you can still play those when you guys don't have any signal, right?
Yeah, that's right. We can record and live stream and do both at the same time as well. So for an event like a docking, we will record, because you do occasionally you might get a loss of signal just in the middle of it. So we want to make sure we record and then just download that if we do lose signal.
Yeah. So D, I want to bring you in, because it's already like 30 minutes into the show, and I'm really curious about what the audience is asking in the chat. I'm already looking here at the YouTube chat, but you have our panel, so go ahead and ask some of the questions from the chat.
Yeah, so we actually have so many questions in here. A first one I want to start with is from Johan, who's wondering if modern cameras make it easier to see stars, for instance. So in this case, of course, you're focused on the Earth, but does that modern sensor technology, improved dynamic range, help you out with potentially showing different atmospheric events or stars in the background?
Oh, thanks for the question, Johan. Yeah, it does help. Filming a lot of people who watch it say, why aren't you seeing stars? And it's obviously just, it's an exposure setting, because you need long exposures to be able to capture those small amounts of light. And you sort of, and most of those beautiful images that you see, where you see Earth lit up and stars at night, are post-processed, usually with two cameras, one focused on with long exposure on the stars and another one on Earth. So it's quite difficult to do it all at once, and we are still learning and improving, and we can update the software on board Space TV 1 at any time, so we're constantly learning and improving, but we're sort of doing it in real time, as in we're live streaming, and we can then see what we need to do to try and make it better. And actually took us quite a while to get to the night settings, or the camera's automatically changes settings when it goes to night, for example, when we're looking down at city lights. And there's still improvements to do, but it is picking up city lights. And I was watching it last night, and it was actually over the ocean, and we saw an amazing thunderstorm and lightning, which is really, really cool. And there's other variables as well in terms of that. Specific to space, really, in terms of the, for example, the atmosphere and the reflectance on that. So we actually have what are called lookup tables on board, which we can actually change, for example, what the exposure setting should be every 1 second. So although you can put it on auto exposure, we don't, and again we're getting that optimized. And the only way to sort of test these things really is to do it, to get it into space and do it, because these are things you can't really test on the ground. But that's the idea is we do as much processing on board as possible, so what you see live is live. But thank you, Johan, for the question.
So I'm curious now. Of course, we've got the panoramic camera, but what sort of sensor size roughly are we working with for someone who's using cameras? Is it more like a full frame camera or something more similar to a cell phone?
Maybe somewhere in between.
Okay.
Yeah, and we're actually using two different sensors on board Space TV 1, and on the next mission we're working with one company's sensors in particular, but we're flying another new sensor, and I think those sensors will change, and the system is designed to be able to, because we design the electronics board on which the sensor sits that then talks to our computer. We're trying to make that agnostic, because there are obviously greater quality sensors coming out. So we focused on 4K sensors, but obviously there are 8K sensors one day coming out, and we want want to do that. I think with the next mission, we're planning to have to be able to put together sort of say 3 cameras for the horizon, each with a sort of 55-degree field of view, so we can then stitch together a sort of greater than 8K image of the whole horizon. But equally, you could just live stream from one particular camera if there was, say, whatever in your field of view there is the hurricane that you wanted to film. So you could stream that in 4K or do a full horizon image at even greater quality. So we're continuing to come up with ways of trying to make it even better.
That's awesome. So, I mean, I love having higher resolution cameras in space. It's such a great thing to see. We have Ross in here wondering though, and a couple other people have asked similar questions, like beyond just getting the cameras into space, like that's an expensive venture. What sort of business model do you have in place to recoup that cost and be able to continue, I mean, sharing these amazing views from space?
That's a great question, Ross, and thank you. So the business model is making money from TV revenue, sponsorships, and subscriptions. So it's a media model really, but it's also quite similar to a sports team model where they get share of TV revenue, they have sponsors, and then you sell tickets, which in our case will be subscriptions. The whole key thing with the business model is it hasn't really been done before, which has made it makes it more challenging sometimes with investors, because if you're doing something new that hasn't been done before, they like to see a proven market. Well, I know, why are you selling to government or for defence or security, which would be far easier to raise money to say, right, we're just going to develop video cameras for defence and security. But we were keen to stick to our principles of, look, we're doing this for the people, to democratize space and empower people to witness planetary change. So that's the business model. So, and I think the actual philosophy is that we can create, a large company with this. It's all about getting mass usage. So whilst it might be easier to sort of sell to defence and security, you're only going to have a small number of government customers that are interested in that imagery. Whereas we think we're creating something which is accessible by, I guess, 3 billion people with smartphones, which in the next decade will be probably 4 billion plus people with a smartphone and internet access, especially with the likes of Starlink and Kuiper and those high-speed internet coming, which are expanding the size of the internet. So we've got a big potential audience. So the question is, as long as we get enough people watching it, then we can make money through TV revenue, because we have it on YouTube. We're also talking to. We're in the process of getting this put onto connected TV platforms. We're working with it's not been announced yet, so I'm not allowed to sort of say names, but should be soon. And it should launch as a connected TV channel in the coming months, which will then make it accessible on TV as a free ad-supported TV channel, and other platforms. So that there's that. We can have direct sponsors as well who want to sort of associate and align themselves with the values of what we're trying to do, which is we're raising awareness of the fact that we live on a planet, that it's beautiful, that we need to take more action and try inspiring people to take action to protect the world, because we're guardians of it for future generations. We're also planning subscriptions. If you take the data, where there's a lot we can do that we are working on, which around AR, augmented reality, and VR experiences. And so the idea is ultimately that augmented reality and VR services within headsets, being able to watch live views with steerable cameras of spacecraft docking or spacewalk. Imagine doing that in a VR headset. So that would be a subscription service where consumers can pay a few pounds through Apple or Google to be able to access that service. But we wanted to be the main, actually watch the videos. We wanted to make that freely accessible. That's been the plan since I first came up with the idea, because you can't really sort of claim to be democratizing and making accessible stuff if it's not freely accessible. And actually, some of the largest businesses in the world are free to consumers, whether you're Google or other media, and it's all about, as long as you get enough traction and usage and providing something that people are interested in it and want to sort of check regularly. So I'd be grateful for all your viewers to please do check out our YouTube channel and subscribe and because the more people that like it, the more viewers we get, the faster our growth, and that's really helpful. So we can deliver even more cameras into space and get 2 live streams going, and then 3 live streams going, and that's what we're planning to do. But that's the business model. I hope that so it's a freemium model with free and paid for services. And as we do capture more data, I've said I wasn't being dismissive about going to government customers, because as we capture a lot more data, there are opportunities to work with government agencies such as meteorology, particularly from when we have cameras in geostationary orbit, but also for environmental monitoring or wildfire response. There are government agencies that would find real-time data of location of fires and things, especially in remote areas, quite helpful. But right now, with one live stream, we really don't have quite as much data as governments would require to do that effectively. But that is something that we'd like to do in the future.
That's awesome. I mean, you answered so many questions. Keith actually had asked about if you were planning any apps or things for MetaQuest. So that's awesome. And then you also touched on this. Joseph was wondering if these high resolution cameras potentially offer benefits for maybe improved weather forecasting. And you mentioned like wildfires. Could you maybe talk about how these cameras are different than those that are used for weather forecasting?
Thank you for all those questions. And regarding the apps, by the way, there is an iOS and Android app. It's not top of the app stores yet because we just released them like in the last week or not. But we do help and good reviews. But if you search for Sen or Sen Space, you should find them there. Sorry, Dee, in terms of your question about weather, well, our imagery is just optical. So we're not, and a lot of meteorology, they have different types of sensors. So they're, for example, able with near infrared to monitor cloud depth and thermal and other factors. They have satellites. I think there's about 7 weather satellites in geostationary orbit with the Japanese, the US, and the UMETS out the European Society, meteorological organization. And they take pictures every few minutes, but so they take optical pictures, but also they capture it. These are real science grade things. And of course, these are probably like each $1 billion satellites. The one advantage we have over that is it is only optical, but it is in real time. So I think there could potentially be a value of actually, are the clouds exactly where they say they are, and do they look like they're meant to look like? It's a very basic form of weather forecasting. If you fly over the Sahara Desert and there's no clouds, you know it's not raining. And I think there's about 70 or so countries in the world that have no such sovereign meteorology capability. And some of the information from other organizations like UMETSAT is shared with them. So it could be helpful for that. I think where it would be most helpful, where we're thinking of that, and we have talked in the UK to the Met Office, which is the weather office here in the UK, about cameras in geostationary where you see the full disk of Earth. If you could have those in several locations and actually have real time, as opposed to the best at the moment is about every 5 or 6 minutes a picture, then that could be helpful, especially if you have a steerable camera as well. So we'd have one view looking at the full disk, and then a steerable camera with a higher resolution that could go to 250 meters a pixel. They think that would be quite useful for detecting fast developing convection storms and nowcasting, that they call it, rather than forecasting. So there is potential value in use cases there. And I think the highest resolution at the moment are from meteorology. Most of them are about 1,000 or 750 meters a pixel. There might be one that does 500 meters. So they said if you go to 250, that level of detail for tracking hurricanes or detecting other storms, it could be useful. But right now, it'll certainly tell you whether there's cloud overhead, and if that's of value to weather organisations, then obviously we'd love to work with them. But it's a bit like I mentioned with other governments. Government agencies, you probably need a bit more data and a few more cameras to really be useful to feed into that meteorological model.
Awesome. Well, there are so many questions in chat, but at this point, I'm going to throw it back to Alex, because I know we also have a lot more that we want to ask here.
I have here the list, and there's a lot of things, of course. Charles, thank you with all of the, because one of the things that I'm finding out is that you're banging out a lot of questions at once. So I want to go to one of the other topics that I'm really curious about, which is precisely about the signaling. Like, how do you guys, for example, for the individual satellite that you guys had with those camera systems, how does that differ or compare to how you do it on the ISS? Like, how do you actually go and live stream something? Like, do you put it a satellite, then a ground station, or directly to a ground station? How does that work?
Yeah, sorry if my answers are far too long and that answer too many
No,
questions
no,
at
no,
once.
no, no. It's okay.
But
It's okay. We are used to
I
that
get
here.
carried away. So the first satellite, we use a simple X-band radio. So that's a sort of play nicely frequency. A lot of people use X-band. It's registered with the ITU and with Ofcom in the UK. There we send the packets of data down in a certain way that we work with the ground stations to make sure it's sent and received in a certain way. You have to be pointing at a certain way towards the ground station and be within a certain distance of it. And yeah, and that gives us around 25 to 25 megabits a second downlink as we fly over a ground station. So we can downlink quite a lot of data in that time, or live stream. The difference to that on the space station is we're delivering the stream essentially over Ethernet to our host, and they are using the NASA TDRS, which is the intersatellite relay system, to downlink it. That's because that's the only way of actually downlinking data from the International Space Station at the moment is NASA's TDRS system, and we know that they have plans to look at alternative or newer forms of relaying data, and our system would be able to use any alternatives that are implemented over the next few years until the eventual end of the space station.
Yeah, and that is precisely one of the other questions that I had as well, that, you know, the ISS obviously has an expiration date. It's currently being planned to be deorbited in 2030. Do you guys have any plans to have the system in other stations? For example, like Vast, Axiom, this kind of companies that maybe you want to partner with them, and hey, can we put our cameras in there? And I don't know, like, is that something that could be done?
Yeah, we'd love to do that, and we are in discussions with all of those that are building private space stations, because we'd love to get our cameras as a hosted payload on there. And the way it works is we pay a fee to actually have the camera hosted, but the result is then that we own the data. But it can also be helpful because with those we can also then provide them with a camera system for their own purposes as well. So yeah, we're keen, and the plan is to get a lot more video cameras and live streams into space, both on the International Space Station, on private space stations as they emerge, and into different orbits as well, like geostationary orbit and lunar orbit one day as well. So we've got quite a lot of ambitious plans. We're working at the moment on the next mission to the International Space Station, just because that's there and operating. We want to build on the live stream that we've got and add additional capability there, like I mentioned, with steerable cameras and everything else. But yeah, we would nothing's agreed yet, but we would love to work with all of those companies like Vast and Axiom Space. So yeah, we're looking forward to hopefully getting cameras hosted on them in the future as well, because I think it'd be really cool just to have, again, you're in a different orbit at a different time, and just have additional perspectives.
Yeah.
So that's what we're working on.
Yeah, and that was precisely something that I was thinking about, like having in different locations and everything around the globe. Are you also planning around other places that are not just the Earth, like the Moon, Mars, maybe? Obviously, with their corresponding delay, because there's some time for the signals to go in and out. But is that even in the cards?
Yeah, absolutely. I've always seen it as like a multi-world thing, and we definitely want to get around the moon. You need to partner with people to get around the moon, and
Yeah.
as you know, there's, as well as government agencies like NASA, working on lunar programs. There's also private companies that some are often funded by NASA as well, like Intuitive Machines and Astrobotic, that are going to the moon. So there are opportunities there. And yeah, we'd love to get cameras not only into lunar orbit, but we'd love to get onto the surface as well. We'd love to have
Wow.
cameras on lunar rovers and be able to have a steerable camera there as the rovers going around as well. And then one day I also thought it'd be great to have a camera on like a helicopter on Mars and
Wow.
and when I watched the Martian film with Matt Damon, I read the book and then I watched the film. I thought this is when SEN's up and running, we would actually have the like live video and relays from the Martian surface. So this problem would have been solved much quicker. But of course, getting data back from Mars is a complex problem. So that's many years into the future, because even just relaying the data is in itself a whole technological engineering challenge,
Yeah.
rather than just capturing it. But it's doable. All of the technology is doable. It just takes time and needs money. So we need to make money, make SEN profitable, so we can then reinvest in going further afield and to the moon and Mars, and that covers quite a long time frame. So
Yeah, I'm really excited about that. I mean, the name of the show is Europe's Future in Space, right? Like, this is something that it's not just about now, but it's also about the future. And I really love what you're preaching to the choir here, that on the moon, on a helicopter on Mars. Yeah, that's pretty much what we love here. And one other thing as well in the future, like, is there a plan to like even go larger in terms of the camera resolution? Like 4K is the limit, maybe not, maybe there's something more, 8K or something like that. I don't know what other
yeah.
things might be coming up.
Well, thank you for your kind words, and I'm glad you like what we're trying to do. Yeah, in terms of the cameras, we will go beyond 4K, but more importantly, I think we do want higher spatial resolution of the ground. So, as you know, we have our own satellite, and the plans for future satellites would be, first of all, involving sort of higher spatial resolution, so we can see more detail on the ground. And obviously they're steerable, so even though we're orbiting, we can still be able to point and stare at the same place for say 60 seconds. But we want those to also have, and this is really something that's been reinforced by the mission from the space station, that we do want live video. So it's not enough for us to record and then live stream once in a while over a ground station. I want to be able to like switch on at any time. Right, we're going over LA. There's these fires happening. Our data could be useful, helpful, valuable. Right, we need to just switch on the live stream as that satellite's flying over there. And so we do need in-satellite links on those satellites. So those are the plans. And it's pretty early days yet. There's a number of companies developing the technology to do that. But in essence, that's going to be a requirement for future satellites in low Earth orbit. So that it's all about getting as much real-time video as possible from as many different places as possible. And especially when you talk about the moon and Mars, I mean, these are amazing stories. Like, if you think of the Apollo landings, like hundreds of millions of people watched those and wanted to see what's happening. And that probably in today's currency, in terms of the population and the availability of screens and internet, is, the equivalent of several billion people. So I think telling that story as we explore the moon and humans return there, it's absolutely essential that that's something people want to watch, and we want to be part of that, telling that story.
That's really exciting. I mean, I cannot imagine the future where, just seeing a feed from the moon is just commonplace. It's like, yeah, I'm looking here at a live stream of the moon, or even I'm looking back at Earth from the moon. Like, there's a camera on the ground on the surface of the moon pointing up at Earth, and I'm seeing myself there, right? Like, how cool is that? And so, I'm seeing a lot more questions in chat. I don't know if Dee has any more stuff. I have a few things to wrap up the show, but we're gonna go to those later on. Dee, do we have more questions?
Yeah, I'll do a little bit of a rapid fire one. So 4K, 8K, that's a lot of bandwidth. So Keith is back here asking about the challenges of dealing with the bandwidth of 4K.
Well, we compress in real time on board, which really limits the amount of bandwidth we need. So down to just a few megabits a second. And that's been the change from traditionally people that take pictures will have a big file on board, download, do post-processing. We do it all on board with a lot of processing power.
Awesome. And then earlier when we were talking about those wildfires, Moldy Space Industries was asking about any plans to potentially include IR cameras, because those in real time perhaps could be beneficial, or is it purely the visible wavelength that you think you're going to stay focused on?
Yeah, well, we think IR cameras on the satellites in future would be quite helpful because we envisage with the video and then doing an augmented reality layer where we're in real time highlighting things, and then having that layer of that extra thermal layer would be really quite useful. But we are a startup and we're a small team, and we focused initially on optical and building up the audience. But then that's the type of layer of information that could be useful to add in the future. So for wildfires, the benefit we have of ours is just basically that it can be delivered in real time, and it's over a wide scene. But it could be that can instruct another satellite company or a drone company to say, right, there's actually, especially in remote areas, you need to get a drone and take a closer look at that certain place because we've just seen it. So that's what we're hoping that the data could be useful for agencies monitoring and responding to wildfires at the moment, just with optical. But yeah, it's a great suggestion and something we're definitely open to considering.
That's awesome. And then the last one I'll ask here is from Dave K. You were talking about the overlays, but have you considered maybe having coordinates or location data so that people who are watching along have a really quick reference to what they're looking at?
Yeah, we think that is a great idea, and I think just the initial we only went live on YouTube a while ago, and I think there's a lot of demand for seeing where you are and the mapping and the overlay. And it's a bit of a conflict between we want to sort of show the beautiful imagery, and we do a little banner across the bottom which sort of says where you are and what's up next. But I know a lot of people are used to seeing it with exactly where the location of the ISS is. So we are looking and thinking that maybe if we do maybe your viewers can tell us what would work, but maybe if we do a second stream, which then has that overlay and a lot more information, and then people have a choice they can either just watch the imagery and enjoy that for what it is, or actually, watch a more annotated, information layered stream. So maybe we need to do both. I think within the SEN app as well, the plan is that you can toggle between those, so you can look at the video and press an AR button and all the information appears, and then you can get rid of it. So you can do both. But on other platforms where you've got one stream, that there are slight limitations on what you can do. So we're trying to achieve the balance, but we're here to sort of take the feedback and try and improve and deliver people what they want, because we want as many people to enjoy it as possible.
That's awesome. Thank you so much for answering so many questions from the chat. I'll throw it right back to Alex now.
Yeah, the last few things that I have is more about, I was talking precisely about the focus of this series of live streams, which is, Europe's future in space. We had 2 rocket companies in the first 2 episodes. We've got now what I call a camera company, but of course there are many other camera companies, as one will call them, but there are more like Earth observation kind of stuff, just still pictures, no video or anything like it. You guys are like live stream from space, and so how does that compare to like the rest of the? Because there's no other company out there, at least that I'm aware, that really does this. Is it being Europe a bit of a competitive advantage in that case? Because it's like nobody else is doing this, right? It's like, what else?
Yeah, it's a good question. We see ourselves as a video streaming company. We don't see ourselves as, we're not trying to compete in the Earth observation market, because there's people doing a brilliant job there, taking really high resolution pictures with radar, with still pictures, with hyperspectral, and serving business and government customers with that. So we're trying to do something different, which is what about the public? They want access to this information, so let's do that. In terms of being in Europe, Obviously, there's many variables as to where you locate a company. One of the key ones is like where you start and where you hire the first talent. And I found that like amazingly talented people in the UK, so that's where we started. And I think but a lot of space companies are essentially global by definition. They have often a global people around the world working for them. Right now, we have people in the UK, France, Australia. We have a team in the US as well. So I think space companies do tend to have global locations, and build, I guess, or headquarter really around where your core team is often based. But there can be other considerations with, I would imagine, with rocket launch companies. Launch regulations can affect where you want to be based. If you're planning to do lots of launches from, Scotland in due course, or so you might want to be, in the UK or in Scotland or have an office there. But I would say there's no disadvantages being in Europe. And there might be advantages around uniqueness. We have so many talented engineers in Europe as well, and I think the main thing is just not thinking. I think maybe 15, 20 years ago, people would have thought if you want to work in space, you've got to go work for NASA.
Yeah.
And of course, we have the European Space Agency. But I think the view should be really now you can work from anywhere, and especially with the modern society and the ways of working. And one of our lead engineers worked for us in the UK for a while, but he's actually from Australia, and so he now works for us from Australia. And none of these are any barriers to where you go. So it can come down to like more business decisions around tax, regulation, where's it good to raise money, are there good tax incentives, where are the local governments most supportive? And I know a number of European governments and the European Space Agency is being very supportive for a lot of companies, for example, through their Copernicus contributing missions program, where they acquire satellite data. So there's plenty of benefits being in Europe, and if you need to have a team in the US like we do, because there's a big market there, and we're working with US companies as well, then we can have a team there. But we're proud to have a headquarters in London here in the UK as well.
Awesome. And that is precisely one of the things. Of course, as another European, I'm really interested in precisely advancing all of this from every corner of the continent, of course, with the collaboration from many other places. You mentioned, it being also having a presence as well on the US and everything. And that is precisely, some of these goals of this series of like, bringing together all of these European efforts, because there's a big change, right, in the world. We've seen the rise of lots of space companies in the US. There's a lot of stuff from China as well. In Europe, it's always like right there in the corner. Nobody talks about that, and it's like we got to talk about that. There's a lot of exciting companies out there, and I think Sen was one of those. You guys went out live with that live stream on YouTube just a few days ago, so I was like, let's have them here and have a chat, because I'm really excited about all of this stuff. And thank you for being here on this episode.
Thank you. It's been great to be on the show, and really enjoyed our chat. And please do, to anyone watching, please do check out our YouTube live stream and like it and subscribe to it. And let's try and generate as much interest as possible, because it helps us go even further.
Yeah, definitely. We have that pin in chat, by the way, for those that are watching live. I'm mostly sure that even if you're watching the recorded version, we'll probably pin it in the description. It's somewhere there. You can head that way. Also, send.com, if I'm not mistaken, right?
That's right.
For the website, there's a lot of things as well there, subscriptions and everything, if I'm not mistaken. So, spread the word, as we say here. We always work with the usual like and subscribe and everything, because we understand that that's the work that needs to be done in order to get this to everybody. Thank you as well, Dee. Speaking about spreading the word, because you were working there with the chat as well in the background. So thank you for being here as well.
Of course, I really enjoyed this stream. I've learned so much, and thank you, chat, for all the questions. Be sure to check out the apps and the channel and the stream and share this with anyone who's interested.
Thank you,
And
Dee.
precisely because we like the support from people, not just to other companies, but also to us as well. Thank you to the members as well. You know, we have always launch directors and flight engineers here on the NSF live shows, both the Flame Trench and these shows as well. Thank you all. The letters are just so small these days, and I cannot thank you enough for the support that you guys have towards NSF. Of course, thanks Jay as well for producing the show, and I've been Alejandro Alcantarilla Romero, the guy with a long name here at NSF, and thank you as well again, Charles, for being as well here on NSF, and see you all in the next one.
Okay.
And here we go.
We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, Atlantic.
Tango down to nominal.
Flight downside at speed off. Bring in SPD off. Off. It's orange! Orange 25! Oh my god! Oh my god! Decollage! What is it? Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.